Okay, for number 5, we know that the body is providing a force down. It's just mass times gravity, which they give us as 675. And the force of the seat is pushing the person up. And they say that's 562. Now you're thinking maybe right now, why is the force seat not equal to the mass gravity pushing down? I mean, it doesn't seem like the student is accelerating upwards or downwards. But the thing is, the student is accelerating. It's because the student is moving in a circle, and that provides centripetal force. So the net force is actually pulling down into the center of the Ferris wheel, because this is the top of the Ferris wheel. So here I just oriented my axes. I said positive is down, and so that's 675. So the net force is 675 minus 562. So this minus this, and that's 113. And so the mass times acceleration, mass times acceleration equals net force. So that equals the net force of 113. So this is part B. In part 5A, the student feels light because the mass times gravity is 675, which he's normally used to feeling, is more than the weight, the force that the seat is pushing up. The seat is only pushing up against the student at 562 newtons. Normally, if the person is just standing still on the street or something, then the street would be pushing up the student at 675 newtons as well. But since the seat is only pushing up at 562 newtons, the student feels light. So in part B, okay, I gave you the mass times acceleration is 113 because this is the net force, the centripetal force. So now if we have to figure out what is the force seat at the lowest point, again, the student is accelerating the same at the top and at the bottom because the student is moving at a constant speed along the circle. So if the student is moving at a constant speed, the net force, the centripetal force, should be the same. So if we set up mass times acceleration equals the net force, this time it's negative 113 newtons of net force because the centripetal force is pointing up because this is the bottom of the Ferris wheel and the center of the Ferris wheel is here. So the centripetal force net is up like that. And again, the axes have to be the same. So the y is down. So that's why it's negative 113. And then the net force is just the mass times gravity minus the force of the seat. They gave us the mass times gravity at 675. The force of the seat we put over here, we put the 113 over here. So the total force of the seat is mg plus 113, 675 plus 113. That's your answer. In part C and D, it's kind of like the same thing, which you can do on your own. If the velocity is doubled, then that means we know that the force is proportional to velocity squared. Force equals mv squared over r. So if v goes up by 2, force goes up by 4. Force is quadrupled. So basically you use that idea, the force being quadrupled, to change the force seat. No. The force quadrupled means that either this goes up by 4 times or this is up by 4 times. No. I think this is up by 4 times because the total centripetal force is quadrupled. So this goes up by 4 times. So then you could use that information to figure out part C and D.